This morning we have the distinct honor of welcoming Dr. Kevin Shoemaker. He's a professor of kinesiology and a Canada Research Chair in the Integrative Physiology of Exercise and Health. He received his BA in 1990 from Wilfrid Laurier University, did his graduate training at the University of Waterloo in kinesiology, and Dr. Richard Hughson was his doctoral supervisor from 1992 to 1996. Following a 3-year postdoctoral period at Pennsylvania State University in the Division of Cardiology, he took up his current position at the University of Western Ontario in 1999. His research focuses on the interaction between blood flow and neural function in health and disease. Current studies focus on sympathetic neural recruitment, strategies, cortical pathways involved in cardiovascular control, blood supply to the brain, and how exercise impacts brain health. Would you please welcome Dr. Kevin Shoemaker to the podium.
Thank you.
Good job.
Well, good morning, everybody. I count this a deep honor to talk about Rich Hughson for the next hour or so. Hopefully you can be as engaged about this as I am. Rich has made an incredible impact on my life, both personally, professionally. Some of you would share the same experience, I hope. Some of you don't know Rich, and I am delighted now to take some time to talk to you about him and let you know about someone who not only impacted me, but has made a tremendous impact for the Canadian Society of Exercise Physiology at the national level, international level. His research has reached around the world. It's in the International Space Station. His impact has essentially been profound as an exercise scientist. And I'm going to show you some of those data. I'm also going to show you some of the experiences that I have, the recollections I have. So I hope you don't mind if I sort of meander through a somewhat disjointed talk about my experiences growing up with Rich. So here's the outline, and it's in no particular order. But this is about Rich. It's not about my data because I think it's really important to honor the people that have brought us to the point we are. I think it's important to honor the presidents of the Canadian Society of Exercise Physiology that have, I mean, look around the room, the society is growing, it's healthy, and every president has been part of that. And it takes a lot of work to do that. So it's my pleasure to do that. I'm going to talk about his activities, his research, his impact, and my experiences. And hopefully, what I learned is something that's close to what we've all learned as graduate students and as researchers moving forward. I want to take a minute to explain my title. It's got nothing to do with Mr. Spats. Mr. Spats comes from a silly American poem about a guy who liked hats. And it's got a lot to do with sort of the ironies of life as we go through life. But the only point here is that it's a guy with hats. And the first lecture that I heard Rich give, he framed it around the 3 hats that he wears. I don't know why I remember this. This is when CAHS was on. I'd never heard him talk before. I didn't really know him. But he talked about himself and the hats that he wears as an athlete, as a coach, and as a researcher. And what I remember about that talk is how it all linked together. And so his research was emanating from his activity as an athlete and vice versa. And it was feeding back. And I'll talk to you a bit about his research programs, and you can see the continuous theme around an interest around the role that physical activity has in health, both on Earth and in outer space. As a coach, and then as a researcher, it all ties together. David Bowie, of course, made the icon of Major Tom popular about an astronaut who was lost in space. That's not Rich, but his research refers to astronauts who, thankfully yet, are not lost in space, and neither is he. So that was just silly, a little cheesy, but nonetheless, that's what titles become these days, right? Okay, let's talk about Rich as an athlete. This will overlap a bit with Mike Hughson's talk yesterday. Oh, and I also got to warn you, I'm not sure who finished their talk first, myself or Phil Gardner last night. But you're going to see some similarities in the way we set up our talks. Small, but you'll see them there. I'm pretty sure I finished mine first, but you be the judge. By the way, I do want to congratulate Phil on his talk last night. I don't know if he's here. But I think if you consider the amount of work that he put into that talk last night to bring it together was phenomenal. And I think he needs strong recognition for that effort that he did for us. Okay, Rich is an athlete. So as a grad student, PhD, we would go for runs at noon. And you never know how good a runner is when somebody runs with me, because it really slows down. He's a gracious runner because he ran slow with me, and I never actually understood what he could do. You get a sense of what a marathoner looks like when they show up in sub-zero weather in shorts. That's how they run. The picture on the left over there, just give me a moment while I figure out, there we go. This picture here, and I thank Rich for sending this to me yesterday, the day before yesterday. This is him in the Toronto Marathon back in the mid-'70s. And I put this picture here because to me it represents one of the features about Rich's mentoring style and his approach to research. He sort of drove himself to oblivion here. He was, I guess, hypoglycemic and having a bit of a hard time in this race. And he almost won it. But the point is that the issue is there's a goal in sight, and we're going to do everything we can possibly do to get there. And I think that's a theme that would emanate through a lot of my experiences with Rich and his research as well. And as you can tell, I've got to clarify one thing. I've heard rumors that some people have thought this was a memorial lecture. Rich, can you stand up so that we can satisfy that right now? This is Rich Hughson, okay? I've heard rumors that some thought this was a retirement party lecture. It's neither that, okay? It's simply about his life. Okay, so on this screen here, we've got I found some data on Rich's times as a marathon runner. And I don't know if you can see it, but if you look hard, the year is on the left column. Here's his time, a marathon time here in the middle, and this is the location of the race. This is all in the 70s. So he's sub 2:30 all the time. Here's a race in Waterloo, 75. 76, he was fourth in the New York Marathon with a time of 2:16. 77, Boston Marathon, 24th. That's still awesome. He's still sub 2:30. Toronto Marathon, you just saw the picture there. But here we start seeing something. If that's not amazing enough, Canadian champion, 1978. And this race here in Japan, the Fukuoka race, they didn't have world championships back then. They had the Fukuoka race where everybody showed up, and that sort of determined who the best in the world was. He came 10th. So we're dealing with a guy who was in the top 10 marathon racers in the 70s. And that's an accomplishment that we need to recognize. The Pan Am Games, he got a bronze medal for us, for him and for us. We'll take it too. I don't know if you can see this picture. I don't know if we can dim the lights. Take a look at his eyes. Like there's nothing there. He's completely spent, completely. And again, he told me, he said, there's no way I was going to finish fourth in that race, and he didn't. And look at his doctor here. Look at the lamb chop sideburns on there. And then here's our nice 50s clean-cut guy. He's looked the same ever since. Okay, as a coach. Now, when I was doing grad school with Rich, I knew about one athlete that he was coaching. I'm sure there was others. I don't know much of his story here. I remember a guy named Peter Mayer, and I saw a picture of him hanging in the lab. I don't know if this is him. I remember he was tall. It is? Okay, good. And he was a Canadian Olympic athlete a couple times in Seoul and in Barcelona. But my recollection of Coach Rich is more to do with his ability to build teams in the lab. This was the group of students and others that I had the pleasure to be with in the mid-'90s. And some of them you'll recognize, excuse me. You've got people from various continents here and people who've gone back to various continents. There's some from different disciplines. Engineering is here, some physiology. We've got a variety, and these two will show up a little bit later. You give a talk here without talking about those two. Anyway, we were, in my opinion, I don't know what Rich thought, but in my opinion, we were a functional team in that we worked together. He let us put a logo together for the lab, and that, I don't know if it's still the logo, but it was then. And I think Maureen had a big role to play. But the point was, the activities we did, a lot of us did a lot of research together. We were each other's subjects. We traveled together. And this is one example of a team that extended, because this was in the 90s. 2005, he got an Excellence in Grad Supervision Award at the University of Waterloo for his ongoing ability to train students and give them experiences that were unique. Because of his connections around the world, at that point, his students were showing up in different labs around the world, participating in collaborative research, and still do. Of the students that I know from Rich, and if you can see the red dots on this, this is where his students currently are, and this is about 1/3 of them. I don't know where the other 2/3 are since 1999. But one just arrived in Dunedin, New Zealand, and there was one from the Arctic Circle at Oulu, so he sort of spanned that distance, and 2 or 3 from Asia that I know of, a couple from Brazil, lots of Canadians, and some of them immigrated into the States. When I started grad school, cardiovascular control in Canada was not really on the map of things that Canadian exercise physiologists were known for. We were muscle physiologists, neuromuscular control. And I think that Rich's emphasis and his persistence and willingness to train a lot of students at the same time have sort of brought us up, at least in popularity, to the same level. Researcher, okay. Now, this is where it looks like I'm copying from Phil Gardner. I'm not. It just shows you, I think, is a really good idea the way he did it. Okay, 1977 is a year to remember, okay? So, and I'm listing a few things here that happened in 1977 that probably, at least it appears, that they influenced Rich's research interests moving forward. So Navstar, the Global Positioning System, GPS, was launched that year. Voyager 1 and 2 were launched and still flying, I think. NASA Space Shuttle, you can see down there, it went for its first piggyback ride and left its jetliner that it was riding on and successfully floated back to Earth. For the first time, first Apple II computers. I was actually talking to the sound guy here. He still got one. I don't know if Rich still has one. Pierre Elliott Trudeau was our prime minister, and a little deja vu there. And of course, Rich Hughson became an assistant professor at the University of Waterloo. He's still there 40 years later, 40 years funded by NSERC, 25 years funded by Canadian Space Agency or more. I'm not sure. Yeah, who knows? Who keeps track of these things? Okay, so all of these things related to space flight and space exploration were going on in the 70s, and Rich was growing up, becoming a professor at Waterloo, interested in cardiovascular control, cardiorespiratory control as well. Now, I've also put in Pac-Man here. This had nothing to do with 77. This is a 1980 thing. This is just my symbol that when it shows up here, it's got to remind me that I need to tell you something that I learned as I went through my experiences with Rich. Okay, so every time that shows up, that's what it means. It's got nothing to do with the talk other than a reminder for me. Kind of a consumer of richness. How's that? Okay, so let's start with impact that Rich has had on a global scale. Of course, we live in a day where when you write a grant, you have to talk about what impact you have or are making with the research you're doing. Sometimes what we end up being impactful in is not planned, but it happens. I want to share with you the impact Rich has had, both at a student level, at a community level, discipline level, and even up to the levels of government. Back in 2012, this consulting group, Higher Education Strategy Associates, put together or compiled a list of the impact that different educational systems and disciplines we're having based on a variety of things. And this is a table that shows the metrics called the H-index, which is essentially how many times are your papers getting cited. If you have an H-index of 5, that means you have 5 papers that have been cited 5 times. It's become one of the standard metrics for each one of us to evaluate each other, and as rude as that sounds. So these are the applied, I can see it here, the applied health sciences. And here's the mean H-index for different disciplines that are in that they put in the applied health sciences. Here's kin. And here's the mean H-index for the discipline. Here are the institutes that have the highest average H-impact there. And if you just track through this, and then here's the researcher that tops them all across the country. This was 2012. So Rich was the most cited exercise physiology kinesiologist in 2012 with an H-index of, 47? That, by the way, is really, really good. Right now, depending what you look at, Scopus, or Web of Science, or Google Scholar, he sits in the mid-50s, depending on which metric you use. That's actually better than 47. That is really hard to attain, and I think that speaks very well of the impact he's had on the scientific community. There are other metrics, though, that become important. One is on the community in general. Is there a general interest by the truck drivers and the high school teachers and the politicians in the work that he's doing? So there's a list of media and newspaper reports and television that Rich provides. I got this originally from Danielle, and then I got your CV as a result of that. And so let me show you a couple of things here. If you can read the list, and I don't intend you to because it would take too long to go through it, but it includes Discovery Channel, Quirks and Quarks, a lot of CBC, CTV, some local newspaper articles. And these are a few of those. And they start in 2005. Here's a few more. And here's a few more. And here's a few more. Ending in 2016 so far. This is all related to his work that he's doing with the questions of human exposure to microgravity and to spaceflight. It's got a great public interest, and he's making a big impact in that area, and I'll show that to you as well. Now, another area you can make impact in, both to your scientific community, to your neighborhood, but also then to the government. There's this group called the Canadian Academy of Health Sciences. It's a group, as you can read here. Let me read the middle part. Induction into the CAHS as a fellow is considered one of the highest honors within Canada's academic community. CAHS fellows who serve as unpaid volunteers are nominated by their institutions and peers and selected in a competitive process based on their internationally recognized leadership, academic performance, scientific integrity, and willingness to serve. What this group does is provide scientific evidence for people forming policy at the government level. And the government can then decide to accept or reject that evidence, but it's there for them. And so this group is charged with the task to provide that evidence for them. So he's been inducted into that last year, I believe. He's one of a handful. There's a few in this room that are part of that, and he's one of them. And so that's a really important role to play for the society, and I'm honored to be associated with a guy who's part of that, because it's, again, it's another level of impact that Rich is having and one to strive for. Okay, now the exciting stuff. His actual research. So when you evaluate job applicants that are applying for a job in your school or your department, one of the things you look for in their CV is there a kind of a continuous theme running through their research? Or is there two, but do they actually link up, or is it disparate kinds of shots at different research projects? Well, I mentioned before he's got 3 hats, and they all align, and you'll see how this comes into play here. So as an undergrad student, he was messing around with cardiovascular risk and road racing. I think this was at your undergrad level, somewhere in there. May have leached into your master's. Anyway, yeah, he doesn't remember. so I don't. Anyway, cardiovascular risk of road racing was one of his early papers. It was touched on yesterday, his work looking at autonomic control of the heart as a grad student using a rodent model. And then you start seeing, as he gets into his academic career, there's two themes that start to emerge. One is he's consistently staying with this idea of cardiovascular control and looking at cardiac autonomic function. Just before I started in his lab, and as the space shuttle was coming up and going down, this problem of fainting was showing up in the astronauts. And so at that point, of course, and still, we think about that as a cardiovascular blood flow delivery problem to the brain, right in his wheelhouse. And he started showing up in his CV and publications, started showing up his efforts to understand that, and both with bed rest studies in his own lab and then others in Europe. Along the way, he's got this continuous interest in technology, which I find really compelling and really valuable. And from the production of software applications and techniques that have really served his research well, and others as well, is an important part of his success, and also this whole idea that he will not be beat by this, he'll figure out how to do it. Coming out of the head-down bed rest studies, he started doing studies in astronauts, and now with short-term and now long-term studies. Similar kinds of focus on cardiovascular control, cardiovascular health. At the same time, because he's interested as an integrative physiologist, the delivery of oxygen to muscle during exercise was one of his major foci. And this is sort of when I showed up. And then we started looking at the role of the heart and blood flow in local muscle to get at a question around the role of blood flow in oxygen kinetics. I'll go through a bit of that later. And then because of events that happened at Waterloo around the strong emphasis on aging research, he had adapted part of his day into studying the aging process. And again, with the cardiovascular, cerebrovascular function. What's really neat about this is eventually these two came into the same question. So watching what's happening with aging cardiovascular systems, watching what's happening in astronauts, this whole idea of spaceflight accelerating vascular aging became one of his key hypotheses, one of the more recent and very important ideas. It's important for a couple reasons. One is, can we use astronauts to study aging? That's one level. But the other level is, if we want astronauts to stay out there for several years, what's that going to look like when they come back? Or can they survive that? So two very important ideas. And the importance of that, I think, can be illustrated here, that the Canadian Space Agency and Canadian Institutes of Health Research actually got together, two arms of the same government got together and put together this workshop around space health and aging research and innovation. And it was because of Rich's research that happened, and just showing a continued interest in perhaps funding these things to a greater degree, and it reflects the very importance of that question. I'll touch on more of those. Okay, 1990s. So this was the PhD cohort in Rich's lab when I was there. And you can see Maureen and Mike and myself, and Dave Northey is there. I'm going to touch on him a little bit later, and then Rich, of course. And this was, I hope your PhD experience was as valuable to you as mine was to me. It stems from Rich, but it includes all of these people. And we had our battles, but we also had a great time together. And so you get different personalities here. We've got, Dave the doer, Maureen the organizer, Mike the challenger, right? and that's me. I don't know. I'd like to think of myself as an encourager, but I'll let them tell you what they think. An awesome time together, and here's my little, there's a, can I go backwards here? I see my Pac-Man. What I learned here that I want to refer to is the value of relationships in a PhD, but not the same people, different people with different perspectives, and learning how to do your own little battles inside the lab under the nurturing environment of somebody who cares about all of you, to make sure that you're seeking the truth and you don't really care, because it's got nothing to do with your affections for each other. It's got to do with the science you want to do, and learn how to process your different ideas in a, not always collegial, but in an effective way, but still be best friends afterwards. That was an important lesson there, and I value that very strongly. One of the other things that I remember strongly from my time with Rich is this idea of being in a battleground, or being in a battlefront in the research that you do. I came in the time when VO2 kinetics was the hot topic, and the hypotheses were it's driven by either metabolic inertia in the muscle or delivery of blood flow to the muscle. Which one of those determines how fast you can adapt in terms of your oxygen uptake at the onset of exercise? At this point, it wasn't an either or it wasn't a mix of the two. It was either or. And I think in the back of all our minds, we wondered about that. But here's the value of thinking about a battleground or a potential hypothesis with two answers and actually splitting it down the middle and taking one side for a while. You actually learn an awful lot about your side, and you go deep and deep and deep into it as you're trying to defeat the other side. And at the same time, you learn an awful lot about your enemy, which in a friendly way. But those who sit on the other side of the fence, you learn an awful lot about what they think about because you study their literature very, very well. The outcome is that you're a better scientist in that you understand both sides of the argument, but exactly where you sit on it. And it helps you to, I think, become a better scientist. So the battlefront, I think, was alive and well in the 90s in Rich's lab, and we learned an awful lot about that. Part of the reason we learned about it was, again, we had similar interests, and we had some tools around Doppler, essentially. And we had this really unique opportunity to actually study the role of blood flow and oxygen delivery to muscle, and to see if that affected oxygen uptake kinetics in any way. And so these are just a few pictures that we've got, and the other thing that you learn here is, Rich is your PI. He can get you some nice tools if you give him data with which he can get a grant. But at some point, you have to do your own stuff. And so look at this stupid thing here. That was our first hand grip device. It's a caulking gun turned upside down with a weight tied on the other end. And we rigged it up so it could go up, arm up above a heart or down below the heart. It cost me $3, and I think we used that for my entire PhD. It cost Rich $100,000 to get that, and I'm very thankful he did. So I was raising and lowering the arm, trying to understand the role of perfusion pressure. Mike was raising and lowering the legs, keeping the arm stable, and doing a variety of other funky things. Maureen showed up just in time to use this electronically braked ergometer that Rich got built, and I was hoping it would be ready for my studies, but Mo took it and did some outstanding studies looking at flow and oxygen uptake in a larger muscle mass where you can actually measure oxygen uptake at the mouth. With the arm, you can't. Great days. We had a lot of fun together, a lot of time spent together, and it's nice to be at the front end of something new, and that's what we were as a group, and it was an exciting time to be there. This is just, I want to throw this in there because Maureen just wrote a really nice letter in the CSEP magazine and about some of the early days and the cardiovascular physiologists. And what she did not do in that paper is talk about herself. And so I want to make sure that you all know that she should have mentioned something about herself as being important in that. This is one of the key studies I think that she did along the idea of the role of blood flow delivery and oxygen uptake. And we don't go through the data, but I just wanted to make sure that Maureen got some kudos and that she just isn't a fine writer. She actually participated in what she's talking about. So she was doing some postural shifts with this new ergometer and measuring blood flow in the legs and oxygen uptake and a variety of things. Of course, it's an integrated system. And so this paper by Mike and Rich became one of the landmark papers as we went through our studies for several years. And then I don't know how Rich got Mike to write this much, but this was an outstanding paper that got a lot of traction. You could develop 2 or 3 courses out of the content in there. And it shows nicely the interaction between oxygen delivery and metabolic inertia as determinants of oxygen uptake. And for me, that sealed the deal on the whole question. There was another Battlefront, and this one was raged a little bit between myself and Mike in a friendly way, but more broadly. So this is the day when Larry Rowell was alive and kicking strongly about the role of the muscle pump to control blood flow. Jerry Dempsey was there, Bengt Saltine, Jerry Mitchell, and these guys held no words for each other in a friendly way in an environment like this, and they would shout across the room and argue and do things. And they would treat your papers the same way. But this was in a day, what the Battlefront then was the role of a vasodilation versus a muscle pump. So Rich let Mike and I enter into this battle. And so Mike developed this paper here, a really simple, cool idea that cost him no money. Just put a cuff around the arm and inflate it and deflate it and see if that increases flow. Just create a pump on the arm. It worked. I was doing similar studies looking at rapid vasodilation, and unconvinced that the muscle pump was that effective, I was doing a variety of studies, and we would go back and forth and challenge and encourage each other on these different questions, and of course we were all part of the same projects. It was another great Battlefront, and this one I got my little Pac-Man thing there. What I learned from this study is the unfortunate reality that about publishing. It took us several years to publish this paper. It was done long before Mike's paper, but Mike's got published first. And it wasn't because we didn't try. This one went back and forth to the reviewers 4 times before it was rejected. And then we had to redirect it. That's all fine. But the stuff you learn about not dealing with reviewers, dealing with reviewer comments and their understanding and their challenging you makes you a better scientist. I really value this paper for that reason, not necessarily the physiology. Well, I think it's strong, but what I learned from that is the same sort of thing. You will not give up on an idea that you feel strongly about. You just have to understand it better. At the end of my PhD, the results around rapid vasodilation and muscle pump were sort of hot in the minds of some of us. And I wanted to do like the big study. And what I wanted to do was understand what is causing rapid vasodilation. And Rich was really supportive of this. What we needed was a pharmacological model. So what Rich did is he took me by the hand and he introduced me to Mike Joyner. I really don't know if he knew him at that point. He also introduced me to Steve Siegel. The point was he was now setting me up for a postdoc opportunity, or at least for a really nice study. At the end of the day, before I knew it, I was at Mayo Clinic talking with John and Mike, setting up a study, and then a month or 2 later, Rich's entire lab supporting this project threw all of Rich's lab into 2 vans, and we drove to the Mayo Clinic because Mike didn't have ultrasound, and we did. So the whole lab went there. We spent a couple weeks, did these really nice 2 or 3 studies. The data are the data, but the experience is what I remember most of a lab working together. I know everybody didn't want to go as much as I did, but they went, and we did it together, and it turned out to be good postdoc opportunities for at least one. Mike had a great time there. But a continued relationship now with Joyner's lab has been very valuable to me as well. Okay, the spaceflight stuff. This is a list of his contracts with the Canadian Space Agency. It's long, and I don't think he's over with that yet. This is really difficult research. It doesn't go fast. You can't predict whether you're going to get subjects or not, and when you get them, it's going to be 2 years till you test them and all these sorts of things. This is not for someone who can't wait to get a paper out. But this has been an influential time. Here's what I learned in this study is that acronyms don't have to make sense. The acronym can be said as a word, but if you look at what it actually translates into, Women International Space Simulation for Exploration. I have no idea what that means. Unless it's a translation from French into English, but that might be it. I don't understand it very well. Anyway, translates as wise. So we had this great opportunity. Again, Rich, he doesn't seem to like to do research at Waterloo. He likes to throw his gear into boxes and trunks and send it over other places. He collects his data around the world now. We went to Toulouse in France, southern France. We studied 24 women from every part of Europe, listening to several different languages all at the same time, sometimes from the same person speaking 4 or 5. I was really humbled by the language skills of people in Europe, and also by these 24 girls that would just go into these bed rest studies. This was a 60-day study. And we interacted with teams from different parts of the world as well to do the research, so it was very active. I go in there with my eyes wide open and a bit of a deer in the headlights at times at how busy it was and the impact and the activity that was going on. But it was an incredible experience for me. We did all kinds of studies. We stuck needles in them, we took blood, we measured blood flow in various places, the head, portal vein, lots in the leg and in the arm, the heart. Micronography was part of it. We hurt them with ischemic exercise, and they kept coming back for more. So they were awesome participants and a well-organized study as well. And it was a busy time, but it was a great time. Okay, so moving from ground-based research to the space station. So Rich has been doing a lot of work with astronauts, as you know. This is Rich and Danielle, who I'll get to in a moment. It looks here like they're reconfiguring one of the modules that is in the space station. I don't know that they ever got permission to actually change anything in there, but their equipment's in there. Somebody put it in. But they've been very influential on the activity on the space station. Here are some more red dots. This is where Rich collects his data now. Here's Kennedy Space Station, Johnson Space Station, Waterloo, of course. I don't know why I've got Montreal up there. I don't think you collect data there. You just collect money there. Yeah, it's where the money comes from. Moscow, and then various places in Europe where the head-down bed rest studies still continue. I've had the opportunity to go to some of these places with him and collect data. It's all started with the shuttle program when they would land with the shuttle. So when they land with the shuttle, you got to have 2 teams because you never know where the shuttle is going to land. You hope it lands at Kennedy. So Team A, Rich and Danielle, go to Kennedy Space Station. They have their own room there because they're there so much. And I was Team B, and we ended up in the desert at Edwards Air Force Base at a place called Dryden, which is the NASA site for testing new planes and things. And that's us in front of our building. You can't see it, but it looks like we're smiling, but we're actually squinting. It's the desert. It's a hot, blazing desert down there. And we're actually squinting because it's so painful to hold your eyes open. And here's our NASA and Canadian Space Agency babysitters. And Heather Edgell is there, and Natalie and Andrew Blaber as well. We're part of that group. So inevitably, you want the space shuttle to land where you are because you want to see it land. You want the astronauts to come into your lab. You want to experience that. Inevitably, it never happened for Team B. Except when I wasn't there, the one time, that's right. I think I can't remember what happened. Anyway, here's Danielle watching, and Rich, watching the shuttle land in Kennedy. And here's Andrew and I watching the shuttle land on TV. Here's Rich having a great time testing the astronaut that landed on the shuttle. And here's Team B testing a CPR mannequin. Here's Team A looking, well, I think this might have been the sandwich that gave Danielle food poisoning, but I don't know. Anyway, they're watching stuff in Kennedy, and because the space shuttle lands in Florida, we have an extra day to kill in Southern California. So you go to places like Catalina Island and you enjoy what happens there. Just so you know, if you ever want to see, if you're into planes and you want to see cool planes, go to Dryden Edwards Air Force Base. They got museums for all these NASA-based flight, the airplanes that have been tested by them. And it's really unique and powerful experience to look at the planes that have crashed, the people that have given their lives in support of trying to discover these things. So we enjoyed the time there anyway, regardless of the lack of opportunity to test anybody. I had a chance to go to Moscow with Rich to look at Bob Thirsk's responses to spaceflight. Again, Rich is always smiling when he's testing an astronaut. Over the course of time, I think Rich in general has looked at about 32 astronauts. These are only some of them. This is only about half of them. But 32 astronauts have become his friends. And so that's a great experience. It takes a long time to do that, and so he's been doing it for quite a while. One of the things that, he's not a very good model for things, but here he is modeling anyway, some tools. So when you think about doing research on the space station or space shuttle, you've got to think, I need as much data as possible with the simplest tools possible. And so from that mindset, he's been on the look and helping to develop a variety of things. But here he is looking at a portable robotic TCD system, some porta-press, accelerometry on the legs. He's very interested in the role that physical inactivity has on your cardiovascular health. And so the reason that he's essentially into bed rest and spaceflight studies is because of this extreme inactivity that these folks experience. The other thing that I learned, and it'll show up here, so here's cerebral blood flow equals cerebral perfusion pressure divided by cerebrovascular resistance, a simple equation. How do you actually test that in the real world? Where we like to control one variable at a time, hold everything else constant, and see what we can do. You can't do that in the real world. You can't even do that in aging research. You have to collect it and make do with spontaneous data a lot of the time. So one of the valuable things that I've learned with Rich is how to think integratively and not simply, but how can you get the most out of your data even if it's not well controlled experimentally. Here's an example of that. And one of the things that has always scares a lot of us in the exercise physiology world is engaging computational methods to understand what we're looking at. Rich was never afraid of that. In fact, he was very good at, he could do it himself, but he could also walk across campus to the engineering groups, to the imaging groups, to the math groups, to the physics groups, and ask for help. He did that with Mike Joyner and me. So this idea of engaging the strengths around you to assist was a very important part of my experience with Rich. Here's just a clear example of a real simple task. You take 2 breaths of carbon dioxide and you watch what happens. Cerebral blood flow goes up transiently and then comes back down. Here's blood pressure, and that's, what is that? Cerebrovascular resistance, yeah, I can see it better here, sorry. But the problem is you get 3 things changing at the same time. How do you calculate that? So this is just an example of Catherine Zui's, I don't know how long it took her to work through this. It took a while, but the point is you're using an autoregressive moving average model to compute the relationship between pressure, flow, and resistance all at the same time. And you come up with answers that you can then write a nice, intelligible paper about impaired cerebrovascular autoregulation and reduce CO2 reactivity following long-term spaceflight by using methods that actually separate them out and compute them from these spontaneous data. As I mentioned, he was doing a lot of work with aging and vascular function in aging. And so this is just to show you that these are his images from ultrasound looking at a nice distensible elastic carotid artery versus one in an older person, which is much stiffer. It doesn't distend during systole. I think this is some of the more compelling data on this topic that Andrew Robertson put out with Rich. This whole idea that, let me just preempt this. You know, when I went through undergrad looking at anatomy of the brain, it's like the hippocampus was for memory, the parietal lobe was for language, and frontal cortex was executive function, very disparate parts. And then you start studying it and you find it's all mixed up. The brain does not behave the way we label it. at least an autonomic function. The same thing with the idea of, somehow we had this idea that the brain could take care of itself in terms of blood flow control. It didn't matter what happened below the neck, as long as the head was fine, it could take care of itself. That's not the case. And this is a good example of that. We have brachial ankle pulse wave velocity here. That's a measure of stiffness. So the higher the number, the stiffer your peripheral vascular system, and peripheral in this case means anything below the neck. And here's cerebrovascular resistance here. And you see this relationship going up. The stiffer your peripheral vascular system, the higher resistance to flow you measure in the brain. And it doesn't matter if you're hypertensive or normotensive. That's what the open and dark dots mean. The idea being that this is an incredibly integrated system, and what happens in the periphery affects the brain as well. So focusing on the right part of this figure, we can see the normal pattern of stiffness developing over age from 50 to 90. It's simplistically, it declines. And here's his astronauts. And these are some of the most compelling data that I think a lot of us have seen in a long time. This is them before they go into space, and here they are about 6 months later. This amount of decline in distensibility suggests that the system is much stiffer now. This is only 6 months compared to about 20 years of aging. That led to this workshop between the CAHR and the Canadian Space Agency to understand the relationship between spaceflight and aging in the context of vascular health. Another potential showstopper for long-term spaceflight is this problem of insulin resistance. For some reason, we have a variety of metrics here, but let's just look at the one on the top left. This is insulin. You have an effective flight here. This is males and females with the different symbols, but circulating insulin levels are higher. Here's your calculated insulin resistance value, the HOMA, and it goes up as well in everybody. If that continues, then there's major problems for the cardiovascular system and other systems with long-term spaceflight. What do we do about that? Okay, so all of this has led then to this nicely, what looked like to be disparate research themes, arms, for a long time that now have merged into this very fundamental question. And I expect that'll keep him and others going for a little while yet. Before I end my talk, I want to acknowledge a couple people that have worked with Rich a very long time, but have also influenced me, and it's through Rich that they have influenced me. And I also know that Rich would want them acknowledged, so I'll speak on his behalf here as well. And I'm sure I'm missing a lot, but these are the ones that I know. Okay. Dave Northey. This was a kingpin in the lab. He was the happiest, most helpful guy you can know. And he's not with us anymore, but this is what I remember Dave like. Just simply helpful and happy, and one of the best guys you want to know. Danielle has worked with Rich for, 25, not that long. 15? Sorry, Danielle. I'm looking at the camera now because that's... she's been his right and left hand in all of these spaceflight studies and all of the bed rest studies. Tremendous abilities to organize and to get stuff done and to make connections to people who don't want to be connected and a variety of things like that. So she's been very valuable and not helpful to Rich, but also helpful to me as we've done some of these things together. This guy's name is Dr. Philippe Arbet. He's a cardiologist from France whom I've gotten to know through Rich a long time, at least since 2000, 2004, somewhere in that time when they got together. I was introduced to him. Fun-loving cardiologist, has been fundamental in doing research in space and doing space flight research on European astronauts and a variety of things. So he's been a gateway, I think, for Rich's team, but also a very incredible collaborator and with a completely different perspective on how to measure things and how to interpret them, which has been, again, helpful as we try to get closer to a better understanding. And then finally, this is Rich after Puerto Rico again. And that's his wife, Nadia, beside him, and she's beside him here 40 years later. And personally, I know the value of a supportive family when you try to pursue a research goal, and Nadia has been that for Rich as well. And I want to applaud her. To do this stuff for 40 years is not easy, and she's been there, so kudos to you. She also opened up her home to us. We didn't have loonies back then, but we had quarters, so we played quarter football on her dining room table, tobogganing at their place, having chili contests, which I always lost because I don't stand spicy food very much. I'm like Rich. So anyway, thank you, Nadia, for opening that up. Okay, so let me bring this to a close. I thought about a song. I'm not going to sing it, don't worry. But I'm not going to play it either, Phil. Okay. So. This may be cheesy, but when Rich was running, Neil Young was writing, and he wrote this song. And it's Long May You Run. And let me read it to you because it's my wishes for my own relationship with Rich and also for him. We've been through some things together with trunks of memories still to come. We found things to do in stormy weather. Long may you run. Long may you run, long may you run. Although these changes have come with your chrome heart shining in the sun, long may you run. Thank you.
Thank you very much, Kevin, for that wonderful tribute to Dr. Richard Hughson. We appreciate it very much. That ends the formal time for this morning. There's a break now, and we'll carry on with our symposiums at 9:30. Thank you.